section 411, again, simplifying and graphing complex numbers. The main thing we're looking for is the letter I. So like I said, I, and it's usually like a script I. So you can see the way I write it right there, almost like italicized. This is equal to the square root of -1. Okay? Now, if you ever see I squared, so let me write this down. Well, that's the square root of -1 squared. What's the square root squared? What happens to the square root when you square it? It goes away. So all we have left is -1. So that means that I squared is -1. So remember those two things. I is the square root of -1. I squared is -1. Okay, so remember those. Those are going to be very important when we're doing our work. Like, I think that's like the hard part of the whole lesson right there. Okay, I think the rest of it you'll kind of see. It's nothing that's like terrible, but here we go. Let me give you guys some examples. So, like literally I'm done with the lesson right there. The rest is just practice. All right. So example 1, we're just going to simplify. And there's many ways that they can make you simplify stuff. Okay, first one, let's do 8i squared. Remember, I is the square root of -1. I squared is -1. Okay? So, 8i squared means square 8 and square I, right? So this becomes 8 squared I squared. Well, what's 8 squared? Go ahead and say it louder. I heard someone say it. 8 squared is 64. I squared. But what's I squared? -1, right? So this is 64 times -1, which is -64, and you're done. That's it. All right, so any questions on this one? Again, we just squared something, right? And we rewrote it like you normally would, 64i squared. But the only thing that's different is that before, let's say it was an x. Let's say you wrote 2x and you squared it. You put 4x squared. We wouldn't change the x squared to anything. But since we're dealing with imaginary numbers or complex numbers, as they call them, I squared has a definition. It's -1. So we just got to change it to -1 and then multiply it across, okay? So let me give you a different one here. If we were to do, say, I'm trying to look right here. We have 3i times I plus, so we're actually going to change it up a little bit, just make it a little bit more complicated, but don't get scared at how weird it looks. It's normal stuff that you guys should know how to do. We're just going to eventually see some I squared, so then we're just going to have to change them to -1s. But don't get scared at the fact that it looks really like expanded. It's not a big deal. Just treat it like you would if it was just an x. So what is 3i times I? What's 3i times I? 3i squared. Okay, perfect. Now, the next part we're going to have to distribute, okay? So 4 times -2, that's -8. 4 times 3i is 12i. All right, I'm pretty much done, but there's one thing I got to change. What do I have to change? What has to kind of like be fixed? The I squared becomes a what? What is I squared? Not a 1, a -1, right? So this is 3 times -1 minus 8 plus 12i. So that's -3 minus 8 plus 12i. And -3 minus 8, that's -11 plus 12i. Now, there is a proper way to write a complex number. This is the proper way. Now, just so you know, I'll put it right here. A complex number, the normal formatting for it is a plus or minus, I guess you could say, bi. So the I is always supposed to kind of end up in the back of the problem. Okay? So negative 11 plus 12i, perfect. Okay, your normal number in the front, that's called the real portion. Okay, so let me label it for you guys. This is called the real, and this is called the imaginary. Okay, so the A is called the real component, and the B is called the the BI is called the imaginary component. Now we're going to be able to graph that number, negative 11 plus 12i, and it might seem kind of weird, but it's actually pretty easy, so don't worry about it. Again, I'm doing problems from your homework, so, you know, if you're thinking like, man, does the homework look like this? Yeah, it does. It does. Let me give you another one from your homework. Negative 7i minus 5i. So negative 7i minus 5i. Now, I'm not multiplying this, okay? I'm just subtracting. So what's negative 7i minus 5i? Remember, treat I like a variable. What's negative 7i minus 5i? It's a negative. Well, if they're both negatives, you add, right? So it's negative 12i. Not negative 12i squared, okay? Because I'm not multiplying, I'm just subtracting. And you're done. That's it. All right, let me try to do another one that's a little bit more complicated here. Any questions on that one, by the way? That in that case, yeah, because you see the minus in the middle, so don't multiply them, just subtract them. All right, so here's another one. This one's going to be a little bit more complicated. Negative 4 plus 3i times negative 1 plus 4i. Now remember, this is one of those problems where you have to distribute, right? Because it's a binomial times a binomial, so you're going to have to send information over. So let me write that down for us here. So that's going to multiply these first, so let's do that first. So negative 4 times negative 1, that's positive 4. Negative 4 times a positive 4i, that's a negative 16i. All right, now let's do the other term, the 3i. So 3i times negative 1, that's negative 3i. And then the last one, 3i times 4i, what should I write for that? It's a positive what? The 3i times 4i. 12 what? Someone said it. Yeah, 12i to the second power. All right? So let's combine some stuff. Okay, you'll notice I have like terms right here. These are like terms. But then also note the I squared. What's going to happen to the I squared? What does it become? A negative 1. So it's going to change that positive 12 to a what? A negative 12. So here we go. This is 4. Now let's put the stuff in yellow together. Negative 16 minus 3 is negative 19i minus 12. I'm going to leave just a real quick hint here. That's 12 times negative 1. Okay, that's negative 12. That way. Not always. If you look part C, they didn't multiply, so an I squared never happened. It usually happens when you multiply stuff. So notice part B. Right there we multiplied in the very beginning, so an I squared popped up, right? And same with part A. We actually got an I squared from the square of it, right? But yeah, part C is an example of maybe an I squared not occurred. And we're going to do one more kind of like that a little later, I think. Let me just double check. But anyway, let's combine terms here. 4 minus 12, that's negative 8 minus 19i. And there's your answer. So yeah, the I squares, like Isaiah asked, the I squares don't always have to show up. They do tend to show up when you're multiplying things out. Now, just a real quick FYI for you guys, okay? I'm not going to do this problem. I'm just showing you guys an example of one. If you see a problem that looks like this, okay? Do not distribute the power of 2 in. Don't do that. You're supposed to write it out twice. And then you can do your multiplication. Okay? I'm not going to do it because we already did a problem like that. That was part D, the one we just did. How to multiply them. We just did it. But if there is a problem on your homework that looks like that, where it's 1 parenthesis quantity squared, you have to write it out twice and then distribute properly, okay? So I want to show you guys 2 more examples. These are on graphing, okay? So, and these are actually pretty easy. Sometimes people think that they're really tough. Actually, let me put example number 2. But they're not too difficult. Now let me give you the hint. Okay, here's the hint for you guys. If they give you a number like this, A plus BI, okay, if they give you a number like that, which is what we normally see, right? We're going to see like a 2 plus a 3i or a negative 4 minus 4i or something like that. That can be rewritten as a point for you to graph like this. Or backwards. If they give you a point, you can rewrite it as a complex number. Okay? So the a plus bi is just like a comma b. If they give you like an a comma b or a point, you can rewrite it as a complex number. Okay, it's pretty easy. Don't get scared with this. So let me give you this example really quick. Graph the following. 2 minus 3i. I want you to graph that. I'm going to draw a little graph for us here. Notice I'm not doing anything weird or different. The only thing that's going to be different is this is going to say real instead of x, and this is going to say imaginary instead of y. But I'm going to treat it the same way that I do my other graphs. I'm still just going to write numbers like normal. There's nothing different. So if they gave me 2 minus 3i, how do I represent that as a point? How do I rewrite that? So they gave me the imaginary or the complex number. Look at the green thing up there. 2 what? 2 negative 3. Now I don't need the I. Notice I didn't put BI on that point. Just the number. Can you graph 2 negative 3 on here? Yeah. 2 negative 3 is right here. There's my answer. Just treat it like any other number, but first you just have to convert it. Okay? You're going to have to convert it. So what if I gave you, let me change this here. What if I gave you a number negative 1 plus 2i? How would you rewrite that as a point? All right, negative 1, 2. And if I asked you to graph it, you would put it right there. Negative 1, 2. Okay, let me give you like about 10 seconds to try to figure out where to put the next one. Okay, I'm going to do just another one here. What if I gave you a -2 minus 4i? Okay, I'm not going to write down the point yet, but go ahead and you write the point down and then figure out where you would graph it. Okay, I'm just going to give you 10 seconds to do that, and then we'll move on to the other direction, where they give you the point and you got to figure out what is the complex number. All right, so the point you're going to be graphing is -2, -4. So you're going to go 2 to the left, 4 down. That's right here. Does that seem pretty easy to graph them? The hard part is just rewriting it, right? Like, make sure you go from the complex number to the point. Just convert it. But it's not a hard conversion. You're literally just dropping the I and writing it as a point. That's all. All right? So one more thing here. Any questions, by the way, before we move on? All right. So last one is going to be example number 3. Write the complex number from the graph. Write the complex number from the graph. So I'm going to do 3 of these. By the way, none of these come from your homework because they're easy enough where you should be able to do them quickly. It doesn't take a long time. All right, so here we go. One red point. There we go. The blue point, we'll put it up here. And the green point, we'll put, I don't know, right there. I'm going to put red. We're going to do red first. I'll just give you a little bit of time just to kind of copy that down. Remember, all we're going to do is rewrite them in complex form, okay? So our first thing is to write it down as a point.
Does it always end in I?
Yeah. I don't know if you were here, but when we were talking about it, the normal form is A plus or minus BI. So the I portion is at the end, and the A term, the normal number, is always towards the front. So it's called the real and the imaginary. So the real first, imaginary second. All right, so what is the point for the red dot? What are the coordinates? -3, 1. So if I want to write it as a complex number, I'm going to write -3 plus 1i, or plus I, correct. All right, let's do the blue one next. What is the coordinate for the blue point? 3, 3, thank you. So then when I rewrite it, I'm going to write 3 plus 3i. All right, let's do the green one. What is the point for the green one? 2, -3. So I'm going to write 2 minus 3i. Easy?
Yeah.
All right, and that's it. That's the whole lesson. This is your homework.